All right, so I went through number 1, I went through number 2. Block any routing for RFC 1918 to the internet. You guys should be able to do that, but for any network in RFC 1918 to go to the internet, I would have to write a standard or an extended ACL. And where would I put it? The extended or standard? Extended? Okay, if you said extended, you're correct. Why? Because it's going to the internet. Therefore, it's a source or is it a destination? Destination, correct. And then I want to stop it probably closest to the entity that I want to protect. In this case, I'm protecting the internet. So I can put it on R1, I can put it on the inside interface of R1 or the outside interface of R1. But since I'm filtering on destination, it's best to put it on an inbound ACL. So I'm going to write this ACL, and I'm going to put it on the inside interface of R1. We're going to R1. All right. And first off, I want to write my access list. So there's several ways you can write this access list. They would all be correct. I could write a numbered ACL, extended ACL, or a named ACL. So I always like to err on the side of naming ACL. Access list. Excuse me, IP access list. Extended. RFC 1918. So I want to deny this traffic, right? So I'm going to deny, and my source is going to be what? Do I care what my source is? My source IP address. Do I care what my source IP address is? No, I don't. So any. I do, actually, I need to make this IP. It's an deny IP, any. And then what comes next? My destination, right? So here's where you gotta think, all right, what does RFC 1918 pertain to? You guys should have learned this, 307 or 347. I'm going to pick on somebody. I'm going to pick on Alex first because he looked up here. Give me one, just one of the IP blocks in RFC 1918, Alex. What? Oh my gosh. All right. You know any?
10.0.0.0.
Okay, that's the IP block. What's the subnet map? Outsider. /8. All right. You know what? This side of the room's off the hook. All right, go ahead, hit me.
72.16.0.0. That's the hard one.
That's the hard. That's the hard. Okay. Well, we got the first part. We have 172.16.0.0/12. Yeah, right there in the middle of the second octet. And what's the third one? Third one's easy, guys. Anybody? What is it? Look up here. No? Okay, I guarantee you, if you go back and you look at your home router's in this block. 192.168.0.0 slash what? 16. This side of the room, you know what? I like this side of the room. I'll work with y'all. Okay, keep it coming. All right. So, if you can remember these, That's the easy part. A lot of times I get the dubious of, okay, what in the world is the wildcard mask? Well, first one's easy. If it's a /8, that's 8 network bits. That's the easy one. We'll come back to this one. This is the second easiest one.
0, 255, 255.
And this one's when you gotta go, oh God, what is that? I gotta do super netting? Help. Well, we know that the first one's gonna be empty. We know that it's something somewhere in the middle. We gotta figure out what that octet is. And we know that the last two are gonna be 255.255. So we gotta figure out what octet number 2 is. So we have 4 network bits there, right? 4 network bits. That means we have 4 host bits. We calculate the number on the host bits, not the network bits. So, who remembers from Professor Pike or Professor Bennett's classes that number stream that you put up there when you were learning subnet? There are like 8 decimal numbers, 1 for each bit in the IPv4 address. Oh God, that I have to remember that. Don't tell me Professor Bennett told you could forget it after his class, because I'm only lying. Huh? What's the first decimal number off on the far right of any octet? 1. And what's the second one? 2. What's the third one? 4. You see how this is going, guys? The fourth one. Let's just stop right there. 1, 2, 4, 8. Now, I know any of you guys can do this because I know we had to have passed basic elementary math to get here. What's 1 plus 2 plus 4 plus 8? 15. That's how you do that. And a lot of people, and you know what? When you can get this and it filters through your head and it clicks in there, you'll wake up in the middle of the night. It could be 6 months from now, it could be 3 years from now, and you go like, oh my God, I got that. It's no longer black magic. To some of you, it does seem like voodoo magic right now. What?
For that specific one, is it always going to be one below?
This one here?
Now it's 16, and now it's 16. Is it always one below?
No, this has nothing to do with this. Has nothing to do with that at all. This is just whatever number. Okay? This could have been 0. And I could have still had this subnet here, depending on how I was going to filter the traffic. But this is a rule in RFC 1918. Okay? That is hard and fast. All right. So, deny IP any 10.0.0.0 0.255.255.255. Deny IP any 172.16.0.0 0.15.255.255. Deny IP any 192.168.0.0.0.255.255. Am I done? Who thinks I'm done? Show of hands. Who thinks I'm not done? Show of hands. Who's absolutely clueless right now? Okay. Yeah.
Okay, maybe I'm looking at this wrong, but it's saying that we're supposed to block all the RFC
18 addresses from going out to the internet.
So why are the 1918 ones not the source address?
Because you have 1918s on the inside that are source addresses that you can use on the inside. You don't want any destination traffic going to these addresses. You don't want to have any destination traffic. And you do this for a couple reasons. The primary reason is you want to make sure that you do, if you ever have a rogue router try to join your OSPF domain, that it does not try to tunnel any traffic or send any traffic to a 1918 address to the internet. 2, ISPs like it when you do this because you filter the traffic at your border and they don't have to filter it inside their networks because they've got to block it anyway. It makes their life easier. Okay? And 3, it's a great exercise because you learn the 1918 blocks from Professor Brown. So you won't ever forget them. You just need to know them. But if I'm writing this, what's the last step I got to do? Huh? Allow any. Thank you. Absolutely correct. Absolutely correct. So now I have to do a permit IP any. Any. Do a show run. Okay. So here's my RFC 1918 IP, or access list. Now I already had a filter on here. So where did I apply that filter? Did I apply that filter? Did I apply that access list? Let's take a look here real quick. Let's go back. Do show run again. Let's look at my interfaces. Okay, so here's my outside interface. Here's my inside interface. Wow, I really goofed up. I didn't put that ACL on there, did I? So let me fix that by going to INTF01. For those of you who were on Tuesday, I need to IP access group filter inbound. So that'll filter that traffic not coming from the internet. Like I said, I want to filter that RFC traffic so it doesn't hit this router. So I'm going to go onto the inside interface, which is fast Ethernet 00. And I'm going to apply IP access group wait a second. I might goof up here. Let's think about this. If I apply that to the inside interface of my router, I'm running an RFC 1918 address here, aren't I? Oh, wait, no, I'm not. I got 201. I'm fine. I'm fine. I can do this. So, let's see. Router 1. IP access group RFC 1918. Always remember to write it to memory. Okay? Now, I may have run into problems. If this network here were RFC 1918 in any of those spaces. In that case, I would have applied the ACL outbound on the outside interface. So I wouldn't break anything. All right, so that's number 3. Number 4 we did. Number 5. Okay, let's go over NAV a little bit. So we went through and we already did the ACL, or part of the ACL. I'm not going to go through the entire ACL because you guys got to earn your keep somehow. But I've got to do this NAT somewhere. All right? And dependent on where you do your NAT and where you do your ACL is very important. It's very important. All right? Now, here's the good thing. I'm on R1. I've already started my ACL for filtering purposes. And I'm filtering based on the public IP. It's fine. Absolutely no problem. All right? Now, I could do a couple of things. All right? I could set up NAT on R1. And the way that a router works is, if you guys remember that order of operations, as the traffic comes in the router, it hits the ACL first, right? And then it does NAT. That's perfectly fine. So I can put the NAT statement on R1 if I put the ACL here. Absolutely fine. Okay? I could have put that ACL on R2. If I put that ACL on R2 and the NAT on R1, it would not work at all. Because I would have NATted up here on R1, and when the traffic got through to R2, if I was to allow the traffic to R2, it wouldn't have worked. It would not have worked. Okay? Now, I could put the NAT statement on R2. I could put the ACL on R2. I could put the ACL and the NAT statement on R2. All right? But if I did that, I would have to put route statements on R1 so that the traffic, when it traverses R1, knows where to get to R2. Okay? This is why when you guys are putting together, and this is a moderately complex network. This is a moderately complex network. You've got to think about, where's the traffic flowing? Where's it filtering? Where's it getting filtered? Where's it going to get translated? And after it's translated, how is it getting to its destination? And so I went through the entire process of explaining the IP table on Tuesday. Okay? So I'm curious to see how you would do this. Okay? And with Packet Tracer, the nice thing is you can actually throw a server on there and give it an IP address. You can test it all out. It's kind of cool. Kind of cool. Okay? So, for giggles, I'm going to put everything on R1. Okay? And this will work. So, I need to look at my translation. And NAT translates from one IP address to another IP address. Okay? A lot of people say, and a lot of books explain it translates from a public domain to a private domain. No. It can translate from a public IP to a public IP. It can translate from a private IP to a private IP. It can translate from a private IP to a public IP. It doesn't matter. It's agnostic in that term, in those terms. Okay? But I have to do a couple things. First off, I have to write the NAT statement. IP NAT. Is it going to let me do this? Oh no. IP NAT inside source static. Inside local IP address, so I'm going to do the first one there, 192.168.50.4. And it asks for the global or the outside address, 201.68.109.147. Okay? Let me explain this. Okay. IP NAT. IP NAT. Just simple syntax of the command. Inside, meaning where are we going to start the translation? Where are we going to start the translation? The source is inside. It is a static or a 1-to-1 match. A 1-to-1 match. It is not dynamic, which we're going to learn about port address translation here next. The local IP or the inside IP, and then the global IP or the outside IP. Again, looking at this from router 1's perspective. All right? And that is the proper way that you write a NAT statement in a router. When you get to ASA firewalls, it's completely different. Completely different. Okay. IP NAT inside source static 192.168.50.4 equals 201.68.109.137. Okay. So that when traffic comes from the internet coming into R1 and it hits 201.68.109.137, R1 is going to look and see if a translation table entry exists. It is then going to say, okay, I have a translation table entry. I'm going to take every IP packet. I'm going to take the destination IP in that IP packet. I'm going to strip it out, and I'm going to replace it with this IP that I'm translating for. And that's literally what the router does. Every IP packet destined for 201.68.109.137 as it comes into R1, that destination IP is going to get stripped out and the router is going to replace it with 192.168.50.4. Then it's going to pass it to the routing table and go, well, where does it need to go? Remember, a router, order of operation, traffic comes in an interface. Is there an ACL on that interface, inbound ACL? If yes, it does the filtering. If the packet passes that filter, it is then passed off and looked at the translation table. Is there any NAT on it? Because the next step that we're going to do in NAT is very important, and if you don't do it, it won't work. You have to tell the interface that it has to look at the translation table. And this is how you do that. You go into the interface, in this case, the outside interface of R1, which is, in my case, it was F01. Interface F01. And I have to do IP NAT outside. That's the outside network. Then on interface F00, I have to do IP NAT inside. That defines this inside statement right here. Okay, if I were to do IP NAT outside source static, right? it wouldn't have worked. It wouldn't have worked. Okay? But since I did IP NAT inside, since I made that F00 the NAT inside, it will. If that packet is coming in that outside interface, passes the filter, passes the IP translation, it gets changed, the packet destination field and the IP packet gets changed to the 192.168 IP. It then gets passed to the routing table, and the routing table looks to see if it has an entry for that destination IP, and then sends it out the proper interface. Okay, and I don't care what router you're using, Cisco, Juniper, and TerraSys, they all do the same thing this way. All right, so that's the major steps of number 5. I'll let you guys figure out the rest of that. Number 6. So we've already done the IP NAT statements on the interfaces. Now we have to create a PAT pool. And what a PAT pool does, we have all these workstations on the 172 network here off of R3. Okay? And let's say that we have 200, or heck, just 100 workstations. How many public IPs do I have? Not that many, right? I sure as heck don't have 100. Okay? But IPv4, I can't use RFC19 addresses on the internet, right? I can't. RFC1918 won't let me. These are not routed on the internet, but my workstations have those IPs. So I've got to translate all these IPs, all these workstations, out one single IP address. Now, if I have a spare IP address, I can use that and just define it in my router. All right? But the easiest way to do this is to apply that port address translation on a public IP address that is already attached to my router. Okay? And I have 2. I have 2. In this case, I have 201.68.109.129, and I have 201.68.109.98. Okay? It is best practice. It is best practice to do your port address translation on the interface that faces the internet. On the interface that faces the internet. Because it's easier on the NAT, on the translation table. All right, so how we set that up is, since I've already have the interface commands done, IP NAT inside. Oh, whoop. Let me get the little configuration mode. Whoops. IP NAT pool. So here, I'm going to define what source IP addresses are allowed to use the translated address. I have to give it a name. I'm just going to call it workstations. Oh God, that's too long. IP NAT pool R3. The stored IP address. Excuse me, you know what? I'm getting ahead of myself. IP NAT inside. I don't have to create a pool. That's what you do if you did a separate IP address. Since I'm using the interface, I don't have to do that. Source. Here's where I get to a list. And I have to name that list, or give it an access list number. Here's where I call it R3. Where's it going to go to? It's going to go to an interface. Which interface? Fast Ethernet 01. And then I'm going to use the keyword overload. All right? Now let me explain this a little bit. Okay, IP NAT, same thing. I'm going to start from the inside. So it looks at that inside interface to start my translations. I'm going to tell it that I want it to use IPs that I define in an access list called R3. It's going to translate those IP addresses to the IP address of Fast Ethernet 01. And I'm going to tell it to use it multiple times. That's what overload means. Okay? Therefore, it's going to create a port address translation. If I didn't put that in there, first come, first serve. Whoever got to the internet first wins. And it would only work for one IP, one source IP. So that overload is very important that you put it in there. Okay? Now I need to define that access list R3. So, another quick question. What kind of access list am I going to write? What kind of access list am I going to write? Huh? No. So if it's not extended, it's going to be
Standard.
Why am I going to write standard? Because I'm only looking at source IP. I don't care where it's going to. I want to know where it's coming from. IP NAT inside source. Where's the source? Where's it coming from? All right, so again, I'm going to use a named access list. IP access list standard R3. Why R3? Because I've already defined it up here. Permit. Now, quick question. Where's my workstation network at? Down there, right? I don't know if you can see that or not. 172.21.0.0. So I'm going to permit 172.21.0.0 /24. What's my wildcard mask? Anybody? For /24 network? 0.0.0.255. 255. That's it. That's all I got to do. Okay. So, I did my access list already. I defined them with an access group in the proper interface. I put the IP NAT commands in the proper interface, the one for the inside network, the one for the outside network. I created my port address translation command. Told it that it's going to only translate those IP addresses that are defined in access list R3. I have a static, one of many static NATs that you're going to have to create. And then I have a standard ACL that defines what traffic for that port address translation is allowed. Seven you guys should do on your own. 8. We'll get into next week when we start talking about a little bit more about AAA. Actually, we've already done AAA, haven't we? All right, I've done 4 and 3 and a little bit of 5. Did 9 last time. I'll save 8 and 10 because it's not due till May 7th, right?
Yeah.
I'll save 8 and 10 for next week. So you're getting out of here a little bit early tonight. Any questions on this? Any questions on this? All right, work on this over the weekend. Work on your homework over the weekend.